Hash tables are how you find this value from linear time into constant time. Today we'll cover what they actually are, how collisions are handled, where they show up in every program you've ever written, 2 classic interview problems that use them, 2 sum and finding duplicates, and finally when to use them. A hash table stores key-value pairs in an array of buckets. When you insert a key like apple, a hash function turns it into a number, let's say 1, and apple goes into bucket 1. Looking it up later? Same hash function, same bucket. No searching. That's why it's average constant time, regardless of how many items are in the table. What if 2 different keys hash to the same bucket? That's a collision, and it's inevitable as the table fills up. The most common fix is chaining. Each bucket holds a small linked list of entries. To look up a key, you go to its bucket and walk the chain. With a good hash function, chains stay short and average lookup is still O of 1. You use hash tables every day, even when you don't realize it. Python dictionaries, Java hashmap, JavaScript objects all hash tables under the hood. Database indexes use them for primary key lookups. Caches like Redis are essentially distributed hash tables. Compilers use them for symbol tables. And anytime you write a deduplication step or count occurrences in a list, you're reaching for 1. To sum, given a list of numbers and a target, find 2 indices whose values add up to the target. Brute force is 2 nested loops O of n squared. With a hash map, we do 1 pass. For each number, check if target minus that number is already in the map. If yes, we found our pair. If not, store this number and its index. Linear time. Finding duplicates in a list, same idea, even simpler. Walk through the list. For each number, check if we've seen it before. If yes, it's a duplicate. Otherwise, mark it as seen. We use a set instead of a dict because we only care about presence, not position. 1 pass, O of n time, O of n space. When should you reach for a hash table? Use 1 for fast lookups by key, average O of 1. Use it when keys aren't naturally ordered numbers. Use it for deduplication and counting. Avoid it when you need things in sorted order, that's what trees and sorted lists are for. And remember, worst case is still O of n if your hash function is poor or someone crafts adversarial inputs. Hash tables are the workhorses of modern software. Once you get the intuition, keys hash to buckets, collisions get chained, you'll start spotting them everywhere in your code. Next up, trees. We'll cover binary search trees, how they keep things sorted, and why they're sometimes a better fit than hash tables.